Hello, everyone. How are we all doing today? Welcome to Lesson 10. I'm doing good. Is my audio okay? Because I was just switching between my AirPods and my normal microphone to see if one of them was better than the other, but it didn't really make a difference. But it was slow for a moment. Okay, well if it's fine right now, then we'll just leave it. Yeah, because it's showing kind of glitchy on my end. Is it like okay, like a robot? Let me try taking these out first. This probably sounds a little bit different, right? And now I'm going to try switching it back. Anything? Does that sound better for at least? It does? Okay. Let me move it a little bit closer to me. Okay. So if that's all squared away, then let's go ahead and get started with lesson 10. Favorite part of the week? Yeah, it is my favorite part of the week as well. So, lesson 9, we covered basically a lot of stuff. We did our import statements. We learned special characters, right? So we have our backslash n to add like an extra line, our backslash t to add sort of like a tab. We worked on a dice rolling game. So I'm at our little projects REPL right here. We used our random library, right? We talked about that. And from our random library, we're using our randint function to generate random numbers. And from that, we're able to create our own dice rolling game. So that was one of the projects we worked on. We also worked on a coin flipping game. So this is just like heads or tails, right? So you just generate a random number, either 0 or 1. We said that the 1 would be heads. We said that the tails would be 0, right? And we actually had the idea to just flip this coin several times and then see how many times we would get heads and see how many times we would get tails if we flipped it like a million times or 10,000 times. And I think it was pretty evenly split. It was like about 50-50. So that was pretty interesting to explore. And finally, the last thing we looked at that we spent most of our time on was this game of Chohan. Now, Chohan, if you don't remember, is a Japanese gambling game where you have two dice, right? The dealer has two dice, and the dealer is going to ask you, do you think it's going to be Cho or it's going to be Han? Now, what that means is the dealer is going to then roll those dice, right? And the normal six-sided die, and he's going to add the sum of those two dice together, right? So if you roll a 4 and a 5, right? You add that together, you get 9. Now, Cho means that the sum would be even. Han means that the sum would be odd. So that's sort of what you're gambling on. That's what you're betting on. Is it going to be even or is it going to be odd? So that's sort of what we implemented here. And we all implemented this in, I think, 2 different ways. We had a very simple, normal way of doing it. And then we transitioned to using a function. And we also kept track of, I think, the amount of money. Yeah, we allowed for the user to bet money as well. So we added that functionality in as well. And I'm pretty sure we were in the review lesson Sunday, and I think we figured everything out, any issues that we had with this. I think we had them squared away. But are we like good to move on to the next couple of projects, or do we want to touch back on the ones we've already worked on, in case we have any questions or anything like that with them? Good with Chohan? Perfect. Well, I'm not seeing anything then, so let me go ahead and we working on our Chohan in this main.py, but I've already got it saved to my own file. I'm just going to go ahead and clear this. And let me give you guys the breakdown for the projects we're going to be working on today. So I'll say projects for lesson 10. I think it'll take us to lesson 11 as well for next week because I have a lot of things, planned. So as always, we have a practice Python project. So we're going to be working on this. We're going to call it cows and bulls. So that's the first one we're working on. Then we're going to create our own card number game. And I'll explain this later. This is something I created on my own when I was a beginner way back when. Then we're going to take our traditional game of rock, paper, scissors, which we've implemented, I think, 2 or 3 times now. But what we're going to do with this that's going to make it a little bit more unique is we're going to have a robot. So we're going to be playing against a robot. So use a random library, right, our randint function to create decisions, sort of like we're playing against a robot. So we don't have to have like a 2-player setup. So we have that. And then the last one I have is something called a Pig Latin translator. Now, if you're not familiar with what Pig Latin is, I've opened up this tab right here, and I'll be sure to paste this into our chat. Basically, I was just thinking about the projects that we've done so far, and I realized that we haven't looked a lot at strings, right? Strings are things that we touched upon a lot earlier, way back in the beginning. Was the last time we actually properly analyzed our strings. So we want to get some practice with those, make sure we're good with them, right? Substringing and all that stuff. So Pig Latin is definitely the best way, or building Pig Latin, or translator at least, is definitely the best way of doing that. So it's a language game. So you have an applied set of rules that you just apply to words. So I'll give you an example. If I say my name is Varun, it gets translated into Pig Latin. Ime, Amine, Isye, Arunve. So you probably heard of it before, but yeah, we'll be working with this because again, look, you're just taking your strings and you're just moving them around and adding things to them. So that's what we have in store for lesson 10 and if need be, lesson 11. Now, at the end of our previous lesson, I had asked you guys to take a look at, if you had the chance at least, this game of cows and bulls. And I'll post the link in chat as well, so you can reference that for later if you need to. Did anyone have a chance to take a look at this? Not even like work on it, just read it. Maybe think about it in their head. Oh, was it dark outside? I built it already. Okay, that's awesome. That's awesome. Okay, so here's what we'll do then. Let me clear this. Good job, Luke. That's actually awesome. Cows and bulls. I guess I'm just gonna go ahead and I'm gonna implement it, and then it's published on my profile. That you compare your solution to the one I tried. Yeah, I think I saw you drop me a follow, so I can definitely check that out. There we go, cows and bulls. Let's see the code. How do I see it? Oh, there we go, show files. Yeah, we can definitely take a look at it. We can go back in. You got the Venv too, dang. Okay, how do I open this up a little bit more? Okay, let's take a look at Luke's code. All right, before we get started building it on our own, let's see how Luke implemented this. And actually, before we do that, let's actually familiarize ourselves with how cows and bulls works in the first place. So you're going to create a game called Cows and Bulls. So basically, with cows and bulls, what you do is you generate a random 4-digit number, okay? And it's the user's job to guess that number. So let's say my number is... Actually, let me just keep going with this example. So if the number is 1,234, right? 1, 2, 3, 4. And I guess 1,000, right? I get 1 cow. Why do I get a cow? Because, let me just close this for a second. Let me come here and I can type it out and everything, and it'll make a little bit more sense with what I'm actually talking about. Okay, so let's say our random number We have a random number, and that's going to be 1, 2, 3, 4. Okay. I guess. What am I going to guess? I'll guess 1,000. Okay. So looking at these two numbers, right? I have one that's 1, 2, 3, 4, and one that's 1,000. I would get one cow from this. One cow. Now, a cow is awarded when you guess a number in its correct place. So with my example right here, I'm getting a cow because this one, right? I guessed it to be the first digit in this whole number, and it is. Okay. So now let me bring this down here. And again, the random number is 1, 2, 3, 4. And now I'm going to guess 1020. Okay. Now from this, I'm going to get one cow and one bull. Oops, one bull. So how is this working? Well, we know our one cow is, again, correct number in the correct place, right? So one, it's in this number and it's in the right spot. So I get a cow for that. Now this two, right, in my guess is a digit in our random number, but it's not in the right spot, right? It's not here in the hundreds place. It's in the tens place. So I get a bull for that instead. And so let me do one more example with this. Now let's say I'm like, oh, okay, this 2 wouldn't go here, but it's in the number, so I'll just put it here instead. And maybe I'll put a 4 here, right? With this, I'd have 2 cows, because this 1 and this 2 are in the same spot, but this 4 is not. So that's how cows and bulls works. So let me head back to Luke's example, and let's take a look at that. Perfect. Let's show the files. Main.py. Let's open this up. Okay. Cows and bulls game. Luke is importing a random number. 0 cows, 0 temps. Okay. So what Luke's done here is pretty standard stuff. He's just importing random because, again, he's using that random library to get that randint function. The amount of digits in your random number. Okay, so you're just declaring some variables that will be used throughout the program. Welcome to Cows and Bulls. In this game, you will attempt to guess a randomly generated 4-digit number. Okay. So what I think Luke has done here is actually made this a little bit more functional, where if you want it to be more than 4 digits, right? You want to be a game with 6 digits, then you sort of have that flexibility. With a blank digit with no repeating digits. Yeah, so again, no repeating digits. That's another thing you have to make sure of. Yes, that's smart. That's what I figured because you're using it here. So I figured that it's much. That's actually really good. It's good to have that sort of flexibility within your code. If you correctly guess the digits in the correct spot, you have a cow. That's true. If you correctly guess a digit, but it's in the wrong place, you have a bull. That's true. After guess, you'll get, okay. So generates a number with no repeating digits. Digit counter. Well, digit counter is not equal to the amount of digits. So basically, Luke is saying, Luke is going to run this loop until you get the amount of digits you want in your number. Digit counter, random number. For digit and random number, so basically, Luke is going to create a number, a 4-digit number, right, from 1,000 to 9,999, and he's going to turn that into a string. Why is he turning it into a string? He's turning it into a string because he wants to be able to go over each digit and make sure it's not replicating itself, right? That it's not there multiple times. So that's why he says for digit and random number, if digit is in digits in number, right? So this digits in number has been, where is it? Right here, this list, right? So you're saying, okay, let's say generate 1,222, right? So I have 1, 2, 2, 2. I'm going to turn that into a string. And now what I'm going to do is I'm going to go over each digit, right? I'm going to go over the 1, I'm going to go over the 2, I'm going to go over the 2 and the 2, right? And I'm going to say, if that number was already in my digits list, then I have to break out of this loop. I have to run this again because my number has some like repeating digits in it. So I have to do this again. So that's what's going on here. And again, it may seem a little bit confusing, but when we do it, I'll walk us through every single step. So if digits else digits and number dot append digit counter. Yeah, so this looks fine. You're breaking out of this loop right here. So when you break out of this loop, you come back to this. So you generate a new random number. Yeah, perfect. That looks awesome. While all digits are not cows. So cow is not equal to the amount of, okay, so that's why you have this cows counter right here. Guess A, right. Ensures that the user's guess is numerical. Awesome. This is actually something we're going to talk about today. Making sure that the input that our user gives us is clean. And that's what Luke is doing here by using this isDigit method. And actually, we're going to definitely use that today. That's awesome that you went out and you did that research, because I know that's something we didn't cover yet. All good, dude. Programming at the end of the day is just looking up a bunch of stuff. Like, everyone does it. Ensures that users guess not repeat any digits. This is good. Invalid guess. Count cows. Okay. Count bulls. Awesome. This is really good. Like, very nicely put together. The documentation is pretty good. I'm impressed. The flexibility with the code is also pretty awesome. I mean, that's pretty good. So let's go ahead and still working on doing good comments. Yeah, don't worry, dude. I mean, for what it is right now, it's pretty awesome. I mean, it's something crazy in the first place where you have to have like these insane comments where you're writing whole paragraphs. But for what you have, it tells the story, right? It does the job. And that's all that really matters. So now let's go ahead and create our own implementation of cows and bulls. So as I like to do with you guys, we need to visualize this, right? Let's see this in our head, and part by part, let's bring it into code, right? So cows and bulls, how do we play it, right? We generate a random number. We can't be repeating. Well, that seems like our first step, right? We need to generate a random number that can't repeat itself. Well, random number, so that means we're going to be using our random library, right? So we need to make sure we import that, okay? So we've imported a random library, and now we need to generate a random number that doesn't repeat itself. Well, that's two different things, right? We want to generate a random number, and then we have to check that random number doesn't repeat. So with this, we have sort of two steps when we generate a number. We can just generate a random number using our randint function, right? But then we have to check it. So in situations like this where, again, I'm just trying to do one thing, right? Create a random number, but it takes multiple steps. It might be smart to put that into a function, have a function that does that for us. So let's create a function, right? Again, the point of this function is to generate a random number and check that it doesn't repeat. And if it does, it's going to generate a random number again. So I'm putting that all under the same umbrella of this function. So again, we're going to create a function. We'll call it generate, is that how you spell it? Generate random number. Okay, just generate random number. And it's not going to take any arguments because it's just going to return everything to us. So the first thing that has to do is generate our random number. So we'll say random number is equal to random dot rand int, right? And again, we'll make this a 4-digit thing just for the sake of it being easier. So in order for a number to be 4 digits, right? 4-digit numbers are just between 1,000 and 9,999. If you remember, our randint function, unlike our range function, is inclusive. So what does that mean? If I give it 1,000 and I give it 9,999, then it'll go up to and include that number. So we can put that in there. If we had a range function, for example, then we could only put 10,000, right? Because it goes up to but not including. So we're putting 9,999 there. And again, let's just print this random number out just to make sure, we'll go by slowly and test it all out. So generate random number. Okay, let's run this. 8,046, 8,460, 5,788. We have a lot of 8,000s, but it looks like so far this is working. But look at that. We need to get rid of our whole duplication of digits right there. So is everyone okay with what we've done so far, right? We just generated a function, and again, we're just filling it out piece by piece. And so far, the piece that we've done is allowing it to generate random numbers. Are we all good with that? Okay, perfect. Now, we're actually going to copy Luke's code a little bit, and we're going to turn this into a string. Now, if you remember, a long time ago, I told you guys about another function, and this function is called our type function, type. And this tells us the type of a variable. So if I just print, right, print the type of this random number, and I run this generate random number function, random number function, I run that, we get int, right? So this whole thing returns an integer. What I want to do is to be able to look at each digit, digit by digit. This has to be a string, okay? So I'm going to turn this into a string. Now, if I print out the type of random number, and again, let's print generate random number. It's now a string. So this allows us then to go digit by digit by digit by digit and check everything out to make sure it's not duplicated. So now let's go ahead and let's get rid of this because we don't need this anymore. So let's go back to our visualization. We've generated a random number, but now we have to check to see if it duplicates. If it doesn't duplicate, then we can return it. But if it does duplicate, we have to do it again. So what we need to do is let's figure out how to go by each digit, digit by digit, right? So we have a random number and it's a string. Now, if you remember, much like a list, you can iterate over each sort of character in a string. And it's just like how we did it with lists. So it's for digit and random number. And I can just print the digit. Let me come down here. I'm going to keep this here. I keep deleting it. Okay. We generated each digit. So our random number was 9,271. And we went through each digit and we checked it. Okay. Now, what Luke had done here, where was it? Right here. Is basically he went through each digit, right? And he said, okay, if this digit, sorry, let me repeat myself. So let's say his number was 1,922, right? 1922. What Luke has done is that he would go over each digit, right? And if they didn't repeat, he would add them to this list called digits in number, right? So let's say he has the 1, right? He's starting at the 1 because it's 1,922. He says 1 is my digit. That digit's not in this list right now because it's empty. So we're going to add it there, right? So you have the 1. And then we have the 9, right? That's the next number in our loop. Is that in this digits in number list? No, because only the 1's there. So then we add it there. So we have a 1 and a 9. And then we have a 2, right? Is that there? No, right? Because we only have a 1 and our 9 in our little digits list. Then he adds the 2 there. But then when he comes to the next 2, that digit is already in here. So then he breaks out of this whole thing and then runs this random thing a whole again, this whole generation of random numbers one more time. And we're going to do something just like that with ours. So again, we're going to go through each digit, right? And we're going to save them. Sorry. Excuse me. Actually, one second. I think I have an idea. I have to check something just to make sure this is a thing in Python. Okay, never mind. I had a better idea for a second, but then I realized wrong language. Anyway, so we're going to go through each digit, right? Digit by digit. And we're going to have this list up here we're going to call it digit cache. And cache is sort of like a temporary storage, okay? And we're going to check to see if our digit is in our digit cache. That means that number is a duplicate, right? Then we are going to break, right? We don't have to go over um, these numbers again, okay? So again, digit by digit, we're going to check to see if it already exists in this cache. If it does, then we're going to break out of this loop. Otherwise, else, we're going to take our digit cache. We're going to add our digit to it. Okay? Does this sort of make sense what we're doing? It confused me for a second when I was writing this, that break broke out of the for loop, but not the while loop. Yeah. So what you have here is you have a nested loop in your example. You have this for loop, right? Everything under this block of code is within this for loop. And when you break out of, when you think of a break, think of it just breaking out of the loop that exists within, right? So even though this break is underneath this while and this for loop, right? In terms of like the hierarchy of spacing, it's just going to break out of this for loop because that's the one it's directly underneath, if that makes sense. So is everyone okay with our caching, how we're going through each digit, saving it for a second, so we can later check to see if that digit has been duplicated or not? Again, I should probably run this actually before so we get an example. Can we do it once more? Of course, let's do it. So actually, let me print out a random number so I can just explain it with the random numbering that we get printed out. Yeah, so let's run this. Oops. Oh, I put it before I think it should go right here. Okay. So our random number was 8,386, right? 8386. That's this section of the code right here. And for now, think of this as just temporary storage just to check to see something later. So for each digit in our random number, right? So we have our 8, we have our 3, we have our 8, and our 6. So let's go by this digit by digit. So again, this starts with the 8. So let's start with that. So for every digit in a random number, so that means our digit is 8 right now. So is this 8, right? Is our digit 8 in our cache right now? Well, this is an empty list, right? So there's no way that we could say 8 in an empty list. So nothing happens here, okay? Because nothing's happening here, we're going to add our digit to this digit cache. So now our digit cache is going to have an 8 in there, right? That's what this dot append does, okay? Now we're going to go to our next digit, right? Because we finished that first sort of loop. Our next digit is a 3. So is this 3 in my digit cache list right now? No, the only thing I have there is an 8. So we're not going to run this little block of code right here. We're going to try this now. So we're going to say digit cache would append our digit, and our digit is 3. So then we have this. Okay? And then we come to another 8. So that's our digit again. We have another 8, right? This is the second one. So is my digit 8 within my digit cache? Well, yes, it's right there actually. And because it's that, we're going to break out of this whole loop right here, because we don't need to keep looking over the other numbers because we already know that at least one number has duplicated itself, right? There's already one duplicate, right? There's 2 8s there. And so are we okay with that? Does that make a little bit more sense how I explain it there, digit by digit? Okay, perfect. So now what we can do, sorry, I have something in my throat. But once we've checked to see if our digit has, passed and everything, I'm just going to come down here, and we're going to put this all within a while loop. Because this will break, right? If a digit duplicates, but we still have to generate a whole another random number then. And again, I'll go through this line by line and explain it. So let me just type it out first. So while the length of my digit cache is not equal to 4, like this. I'm just moving things around. Again, I'll explain it. I just want to have it all like squared away before I go ahead and do that. I just want to make sure I'm doing this right as well. I just want to make sure this is working. 1 second. Okay, perfect. There we go. Sorry, I had a little brain fart there because my note for this, like I have like little code snippets that I use sometimes to just guide me so I don't go too slow or anything. It's not in Python, it's in a different language, so I got confused. Now let's go ahead and go over this line by line. I apologize for that. Okay, so again, I'll go through this whole function. We're going to create a function called generate random number, and the goal of this function is to generate a random number that doesn't have repeating digits in it. Okay, and again, we're doing a 4-digit number. So again, our digit cache, sort of with my previous example, is just like a storage method, right? I'm just using it to check for something a little bit later on. Okay, and while the length of my digit cache is not equal to 4, what does that mean? Well, again, if you remember, every time my number, didn't have a duplicate, I added that number to my digit cache, right? So in a perfect world, right, where I have a number with no duplicates, so say like, again, with this example, 8,371. If I'd gone and added all of those digits to my digit cache, the length of that would be 4. So while it's not 4, we're going to keep generating our random numbers. And again, I'll do it line by line with a proper example, but I'm just doing a quick overview right now. So while our digit cache is not 4 things long, it doesn't have 4 numbers in it, we're going to keep generating a random number, and we're going to turn that into a string. Now with that, we're going to go through each digit in that thing, or each digit in that number that we've generated. And we're going to see, hey, does this digit exist in my cache already? It doesn't. Okay, so I'm going to add it there. But if it does, then I'm actually going to clear my cache. I'm going to clear it. Why? Because I'm not going to use that number, so there's no need for me to keep those digits in there anymore. And then we're going to break out of this loop. So we're going to break out of this for loop, but we're still going to be inside this while loop. And so we'll run this again to get another number with no duplicates. So that's the overview. And now let me do it with a proper example. And we'll say our example number is 1,566. Okay, that's our example number that we're going to use. So this again, digit cache. And we're going to see, well, the length of my digit cache right now, there's nothing in it, so it's 0. And 0 is not equal to 4, so we're good. So this while loop is going to start running now. And again, we're just going to assume that our random number is 1,566. So we're going to say random number is equal to that. And I'll put that right here. Okay, we'll just put that there. We're going to go through every digit in my random number. So we're going to start at that 1. We're going to go through this. So is my 1 in my digit cache? Well, again, my cache is empty. So this block of code will not run. But it's going to take that number and it's going to add it there. So now I have a 1 in there. Okay? Again, we're still in this for loop because we have to go through all of the digits. Now we have to look at the 5. All right? Is my 5 in my digit cache? I only have a 1 in there. So we're not going to run this. We're going to come down here to our else statement and run that instead. So digit cache dot append our digit. And again, our digit is 5. So we're going to come down here, 5. Okay? And just keep in mind the length of our digit cache as we go through this, right? It's only 2 things long so far. So we're still going to run this while loop. So next digit, it's our 6. Is our 6 in here? I don't see a 6, so we're not going to run this. We're going to run this. Now we have a 6 in here. Our next digit is also a 6, though. So for digit and random number, so our digit is 6. Does that digit already exist in my cache? It does. So what am I going to do now? I'm going to clear my cache. I'm going to take this, my digit cache, and I'm going to turn it into an empty list. I'm going to basically just going to clear the board. And I'm going to break out of this. I'm breaking out of this for loop because, again, this for loop is used to check to make sure a number has no duplicates. And since I've already established that this number has duplicates, I basically reset everything. I'm going to break out of this. And then we're going to come back here to the start of my while loop, right? Because we're just breaking out of our for loop right now. We're going to come to our while loop, and we're going to generate our next random number. And we'll say our next random number is 1,560. Okay. So again, you already know what happens with the first 3 digits. So then we come to our last digit, right? Because again, once we hit this random number, we have to go through this for loop. So that 0 is my digit. Is my 0 anywhere in my little cache, my little storage? It's not. So then I can add this to it. Boom, 0. And at this point, I've actually gone ahead and I finished this whole loop because I've gone over every digit within my number. And once I've completed this, it'll come up here to the start of my while statement, and it'll actually check to make sure this sort of operation is still true. And if you look, it says length of digit cache, and at this point, it's 4 long, right? So this is 4. Is 4 not equal to 4? That's false. So then we break out of this while loop, and then they can just return that random number that we had set right here. Everyone okay with that? Are we feeling with that example? Because I was, oh, yes? Okay, perfect. Because sometimes I explain things, I always get like worried that I'm over explaining it or I'm under explaining it or whatever. But if we're all okay, then that's awesome. So yeah, we basically, let's go ahead and test this out now just to make sure it's working. So we're going to say random number is equal to the output of our generate random number function, right? And then we can just print that random number out, right? So there we go. Let's come over here. I would say that was by far the most difficult part of the project, easily. Dude, because, again, we're sort of getting into the stage where everything has to tie together, right? Because, again, programming is not about knowing how to write an if statement or knowing how to set up a function. It's more about knowing how to think. And it's not like, you're born with it. It's something that you just sort of get used to. It's something that's acquired. And that's why the challenge has sort of gone up to the point where, you have to start Googling things to just make sure you understand what's happening. And again, that's totally fine. That's just a part of the process. That's how we learn. So, if you ever have to Google something, don't be like, feel bad about it. It's totally normal. Everyone does it. So let's go ahead and test this out. 7361, 1206, 8942, 1584, 2481. So I'm not seeing any duplicate digits in our number. So that means our function works. And again, Luke had basically implemented the same exact situation. Like, it's literally the same thing. Mine is just underneath a function. But in terms of what it looks like line by line, they're the same thing. So cool. We've generated our random number. So let me go ahead and clear this. Let's move on to the next step in our visualization, right? A digit counter was pretty pointless. Whatever, man. We all learn. So let's go ahead and continue. So again, let's go back to our visualization, right? We've generated a random 4-digit number, okay? And it doesn't have any duplicates. So now we're ready to start taking user input. Okay, so this is where the whole guessing situation comes into place. So again, I'm going to, we're going to create a while true loop. And again, you guys know I'm a fan of using break statements in my while loops instead of setting conditions here because it's easier. But basically what we're going to start doing right now is taking our user input and saving that to a number. So the first thing we need to do is actually take this random number and save it somewhere, right? So we can reference it. So I'll just say here, random number is equal to generate random number. So there we go. Okay. Now we're gonna enter a while true loop. So let's think. Well, we have to start guessing. That's just about it. So we're just gonna take our input, right? Our user input. User input is equal to input. Enter your guess. Okay. And we're gonna save that to our user input. Now, what I liked with what Luke did is he did what's called input cleaning. Not really input cleaning, but just making sure that the input that they give you is valid, that it's actually something that you can work with and use. And he accomplished that by using the isDigit method. Okay, the isDigit method. And again, we're going to use that as well. So what do I mean by the isDigit method? I'm actually going to comment all of this out just so I can explain this really quickly. But let's say we have a string, right? And again, you don't have to follow along with this bit. This is just something you just watch what I'm doing. Okay, so we're going to have a test number, okay? We're going to call it 1977. And this is a string, right? So we're going to say, we're going to print out our test number. Again, we print this out, we get 1977 as a string. Pretty standard stuff. Now, the string has a method called isDigit. Now, if you remember, methods are sort of like functions tied to specific data types. So with our list, we had .append. With our dictionaries, we had .keys, .values, and stuff like that. So with strings, we have isDigit. And I think it's lowercase, or is it? Yeah, it's lowercase. IsDigit. Okay? That's what it is. And it's a method. So it's just kind of like a function, but it's tied to this string. And what this will do is it'll return either a true or a false if a string has numbers in it. So with my example, right, 1977, it's going to print true, right? This whole thing will print true. Why? Because test number is consistent of only digits. There's no letters or numbers, or sorry, letters or symbols in here. If I were to put like an X in here, right, then this would become false, right? Because now it's not just numbers. If I put a space in here, then it would be false. Why? Because it's not just numbers, you have some white space as well, right? Again, if I put like a symbol in here, it's the same thing. So isDigit is a good way to check to see if whatever our user has given us is an actual number in the first place, right? They could type in gibberish and that would break our code. But if we have an ability to check, then we can sort of make sure that doesn't happen. So is everyone okay with our isDigit method? How that is working out for us? Is that okay? Are we all good with that? Can we do it again? Awesome. Yeah, we can do it again. Again, isDigit is a method, right? And a method is just like a function tied to a specific data type. So again, let me use our list as an example. If you remember, we had our students, right? Our students list. And I'll just make this an empty list. I'll just put one person in here, right? If I wanted to add something to this list of students, right, I would say students.append, right? .append, and I would put whatever name I wanted to put in here, right? And so that's how a method like append works with this list, right? Because again, students is a list. Similarly, our strings, have a method called isDigit. And the purpose of isDigit is to basically go through each sort of character within my string and make sure that it's a number. And if all of my characters are a number, then it's going to return true. Otherwise, it's going to return false. So the purpose we're using this for is, if I use Luke's example, which is, as I said many times, a perfect example, he's using that to ensure that our user's guess is numerical. So he's making sure that if our user is guessing a number, they're not going to just start typing in like their name or anything, that they'll actually type in a number that we can use, if that makes sense. And again, I'm explaining it, but once we see it in practice, it might make a little bit more sense. Oh, don't be sorry either. Again, these are just questions. This happens. We're learning, right? Nothing to be sorry about. So yeah, if it still doesn't make sense, give it till we actually implement it. And if it still doesn't make sense, obviously we'll go back and look at it one more time. But don't worry about it right now. Oops. Okay. So user input, we're going to take our guess from our user, right? And we already have our random number, and they're both strings, right? Because again, this saves it as a string. And the first thing we need to do is if our user input is a digit, oops, then we can print this is valid input. And again, this is sort of the, in practice thing that I was talking about. This is valid input. Again, this is just for testing, just to make sure that everything is working. This is not valid input. And this is just to show how our is digit is working. So enter my guess. If I were to type in 1, 2, 3, 4, it says that's valid input, right? 1, 2, 3, 4, it's a number. If I put Varun in here, though, that's not valid input. What's going on here? Again, I'm typing in whatever I want to, and it's getting saved to this user input variable, right? The next thing we're going to check to see is if that user input is a digit, right? If this returns true, then we'll know that our input is valid. And this will only return true if we type in something like a number, right? So if I type in whatever number I want to, as long as it doesn't have white space or numbers or digits, it all comes across as valid input. But if I start typing in rubbish like this, right? Let's say our user put 172, right? That wouldn't be valid. This is our way of making sure that whatever our user is typing is good. It's not rubbish. So does that make a little bit more sense? How I've shown it within the scope of our actual code of how it'll fit in. Okay, so I'm not seeing anything, so I'm going to assume we're all good right now. So again, if our input is valid, then let's go ahead and work on the next set of things. So let's think, if our input is valid, right, they've given us a number, the next thing we have to check to see is if it is, a number that has no duplicates in it. All right, so ensure that the user's guess did not repeat any digits, and that's what Luke has done right here. Now, what I'm actually going to do is I'm not going to implement this right now because, well, kind of for the sake of time, but I actually want to challenge you guys after this, after we finish this project, to go back and improve this by adding that feature in. It's just sort of like a challenge, I guess, and also because I'm a little lazy. Because again, I have control over the input I give, so I can make it as clean as I'd like. So let's go ahead. So if our user input is a digit, and we're going to assume that it's not going to repeat, right? It's going to be valid. Then we can go ahead and we're going to go through each digit and we're going to start comparing them. So again, we're going to loop over every digit in both our random number and in our user input. Okay, so I'm going to create a for I in range 4. And usually when we have our for loops, what I've been doing recently is we've been using for like letter in user input or for letter or digit in random number. We're actually not going to do that this time. We're actually going to use the indices. First, as a little bit of a challenge, right, to spice things up a little bit. And also because we need to pull from both our user input and our random number. So using an indice instead of a direct value allows us to do both within our same loop. So for I in range 4, right, and that'll generate 0, 1, 2, 3, the indices, we'll say random number digit, right? So that's our digit from our random number is equal to um, random number at that index, at the index of I, okay? And then we'll have user input digit, and we'll have that at the user input at the index of I. And again, we'll build this, and then I'll go back and just explain it one more time. So again, so basically what this has done is, let's say let's clear this. Let's say my random number is, 1,278, okay? And my user guess is 1,208, okay? This is going to basically pull both digits in the first place. So again, for I in range 4, that's going to generate 0, 1, 2, 3. We know that at the index of 0, we get the first digit in our number, right? So with our random number digit, what's at the index of 0? It's this 1. For our user input, what's at the index of 0? That's this 1. So we can then use that to sort of compare the two, if that makes sense. So then we can say that if our random number digit is equal to our user input digit, right? So if they're the same thing and they're in the same spot, right? Because we're going spot by spot by spot. So if they're the same thing and that means they're in the same spot, then we have a cow. So we're just going to print that out right now. We're not going to save it to a number or anything. We're just going to print cow. That's if they're in the same spot. Now, if you remember, we also have to worry about our bulls, right? We have to check to see if maybe a user number that we've guessed is someplace else in our random number digit. So we'll say else, right? Else if, else if my user input digit is in my random number, not my random number digit, my whole random number. So if it's anywhere in there, that means we have a bool. That means that number exists in the random number, but it's not in the right spot. Okay, so let's go ahead and run this. And actually, let me print out our random number so we know what we're working with. Print random number. I can use this to sort of explain everything. Okay, so let's start from the top and go through this line by line with our example. So my number is 9,143. Again, 4 digits, no repeating. And I've gone ahead and printed that out. We're going to enter this while loop here, okay? And the first thing we're going to do is take our user's input. If our user types in bad input, for example, like this, we're going to come down here to this else statement. It's going to print this is not valid input because this is digit method does not return true. So it comes down here, but then it's going to return back to the top so that they enter another guess. So let's give it a valid guess. We'll say 1,439. Oops, 49. If you remember, if you see all of these digits exist within my actual number, they're just all in the wrong spot. So I should hope to see bull 4 times. If I run this, I get 3 bulls and 1 cow, and I see this 4 is in the same spot for both of these. So that's how we have that cow right there. So what's happening? Again, this part we're okay with. It's where we're entering this for loop that might get a little confusing. So why am I using a for loop that goes over in a range of 4? If you remember, our number is 4 digits long, right? And our indices always start at 0, right? 0, 1, 2, 3. So if I have this random number here, this 1 is at index 0, this 2 is at index 1, this 7 is at index 2. So I'm using indices because it allows us to pull values from both our random number and our user number. Okay? So in this first run, this I will be 0. Okay? And so our first digit in our random number, that's a 9. Our first digit in our user input, that's a 1. Are they the same thing, right? No, so we don't get a cow there. But does that user input digit, right, that digit, that 1, does it exist anywhere in my random number? Well, yes, it does. It exists right here. So then I have a bull. And then we just sort of repeat that for the other numbers. So how are we feeling with that? Does that make sense, what I've sort of talked about there? I don't know, maybe my chat's not loading. It's like looking kind of glitchy. Let me open it up on a different browser really quick. Maybe I missed something. Okay, we're all good? Okay, okay. I just wasn't seeing anything in the chat, so I was just not sure.
My chat is not working.
Hold up. I don't have my AirPods in, so I can't hear anything. Maria, do you have a question? Hello?
Hello?
Oh, can you hear me?
Yeah, my chat is not working.
Oh, okay, okay.
But yeah, I'm fine with it.
Okay, you're all good? Perfect, perfect, perfect. Okay, so let's go ahead and continue. So now what we have to do basically is we just have to add a counter, right? We have to count how many cows we have and count how many bulls we have. So I'm going to come back up here to where we had our random number. And we're just going to add like a counter for the amount of cows. And actually, we're not going to put it there. We're going to put it, where do I want to put it? Let's see where Luke put his. Okay, he just put it right here. Okay. So we're going to put our cows right here. We'll call it cow counter. We'll set that equal to 0. And then we have our bull counter. We'll set that equal to 0 as well. Because again, we just started, so we have no values there. So again, where we have cows, we'll just add 1 to our cow counter, right? Plus equals 1. Where we have our bull, we'll just add 1 to our bull counter. That's pretty straightforward. So let's get rid of, actually, I'll leave these in here for now. And so we've done that. So now we can go ahead. And so once we've compared all the digits, right? So once we're out of this for loop, then we can go ahead and print you had X cows, you had X bulls. So we'll say print you had, we'll make this a nice F string. You had, we'll use our cows first. Cow counter, cows. And I'll copy this, bring it down here. And we'll say you had bull counter, bulls. Okay. So what have we done here? One more time, let's just reiterate. So if our user has given us a number that's valid, right? Then what we're going to do is we're going to go over each spot. So what I mean by spot, I mean we're going to start the first digit right? In both numbers, we're going to compare them. If they're the same, we're going to say that they have a cow and we're going to add them. But if it's not a cow, we're still going to check to see if that digit exists somewhere else in our random number. And that's going to be a bull. And we're going to go through each spot by spot. So we're going to start here in our thousands. We're going to go to our hundreds, right? We're going to go here. And we're going to go, to our ones. We're sort of going like vertically through, if that makes sense. And then we're going to take our counter and we're just going to print it out. So if I run this, oops, where is the error? Oh, got to leave my parenthesis there. So enter my guess. I'll say 1, 2, 3, 4. So I had 2 bulls. So one of these, so 2 of these numbers are in the actual number, but they're not in the right spot. So let me put 5, 6, 7, 8. Okay. Is there a 9 or a 0 in there? I have 2 bulls now, 2 cows. That means 2 of these numbers in the right spot. So the 1, 2 are the cows, right? Because we can see they're the last 2 numbers. And the bull is this 0. So it'd be 0, 9, 1, 2. That should give us 3 cows. We have to find the next bull. I think it's 4. 0. Wait, this makes no sense. 0, 4, 1, 2. Oh my god, this is so confusing. But you get the point. It's working, okay? Because this is like a tricky game, and I honestly don't want to play it because I'm so bad at this game. But basically, we've basically checked everything off, right? Everything's working so far. The last thing we sort of have to implement is just a way to exit our while true loop, right? Because once they've guessed everything, then we can break out of it. So the way we can do that is we can just say if our cow counter is equal to 4. Again, why am I checking to see if cow counter is equal to 4? Because again, cows tell us that our number is in the right spot and it's the right value. So if you have 4 of those, that means you basically have the right number in the first place. So once our cow counter hits 4, then we can just break. And that'll take us out of this whole while loop. So to test that out, let's go ahead and print our random number so we know what we're going to guess, right? Clear this as well. Our random number is 1,986. So let's say I put 1,968. I should hope to see 2 cows and 2 bulls, right? And that's exactly what I get. Now, if I go ahead and put 1,986, right, so that's the whole thing, I get 4 cows, and it looks like we've exited the code. We'll put a little victory statement there. We'll put print. You guessed it. Yay. Let's get rid of these as well. Yeah, that's basically our full game of cows and bulls. Any questions? Or anything you guys want to go back over? Or are we all good? Let's see how much time we have. We have 27 minutes. So let me look through. Maybe we can find something that's quick. Okay, I'm not seeing any questions, so I'm going to assume we're all good. So I'm going to go ahead and do is, again, we got to save our good work, guys. This is pretty awesome stuff we're doing. I'm going to go ahead and create another file. We'll call it cows and bulls, right? .py. Take all of this, Command X, and we'll actually paste it into there. It says you raised your hand. I'm going to be honest, I'm very unfamiliar with how to use teach.
Can you actually go at the end of the code? I want to check it again.
You want to go, which lines you want to check out?
Just the end.
Oh, just the end? Do you want me to explain it, or just you need to just copy it?
No, I just want to check it again.
What do you mean? like right here.
Yeah.
Okay, so what this is doing, again, if you remember our cows, right? The point of our cows is to say that our number is in the right spot and it's the right thing. So again, my random number in our little example was 1,986. That was the random number. If I guess that, right, that means I have 4 cows. That means I get this. So I can just say if I have 4 cows, that means I have the right number then. So if my cow counter is equal to 4, that means all my numbers in the right spot. I can just say, you guessed it. I'm going to put this break statement here because, again, we're just putting a while true. So if we don't want that to run forever, we have to have a break statement somewhere. And so we'll use this to exit the entire loop. And that'll basically end the whole game. So that's what the point of this is, to check to see if everything sort of matches up. Does that make sense?
Yeah.
Okay, awesome. So I've gone ahead. Okay, so that's all saved. So, you know what? I think it'll be fine if we go a little bit over time because we've done it before. So the next couple games, we had the card number, we had rock, paper, scissors, or we had pig Latin. I think we should just start off with the rock, paper, scissors game because we've made it before. So it's really just about adding in like robot functionality, right? Just make it like we're not playing against someone else. So let's go ahead and do that. We're just going to rebuild our rock, paper, scissors game. It should be quick, pretty quick, because, again, we've done this several times. Scissors. So back to the visualization board. The only thing we really have to do is just figure out how do we add a robot to the mix, right? So we're going to create a function. Well, again, we're going to be working with our import random library again, so we're going to do that. But we're going to create a function called robot move. And again, that's just going to say, is it going to be rock? Is it going to be paper? Is it going to be scissors? And what is that going to return? So what I'm going to do here is I'm going to have a list of moves, right? And I apologize if I'm going a little bit quicker. I just want to make sure that we don't have to, cut halfway through a project and then save it for the next class. I'd rather we just finish them one at a time. But the moves of our robot, well, a robot can do either rock, they could do paper, and they could do scissors, right? Those are the 3 moves that you could have in the game. And what our robot needs to do is just pick one of those randomly and then play that. So again, I have a list. What is something from my random library that I can use to pull random values from my list? Well, that's our random.choice. So I'm going to say chosen move is equal to random. So that's our random library dot choice. And we give moves. We're going to return our chosen move. So what is this doing? Again, I have a function called robot move. The aim of the function is to sort of make a move for the robot. Tell us if the robot wants to go rock, if they want to go paper, or if they want to go scissors. So these are all the moves that it can do, right? From that, I need to randomly choose one. So I'm going to say, hey, random library, can you go ahead and from my moves list, just choose one randomly, take a random choice. And then we're going to save that as our chosen move, and we're going to return that. So if I say robot move, that's a terrible name because it's the same name as my function. We'll just say robot choice instead is equal to robot move. If I print that out, robot choice, we'll get paper. If I run it again, we get scissors. If I get it again, we get rock, scissors, rock, scissors. So is everyone okay with how we're making our robot do stuff? How our robot is able to make its own choices? That's really the only different thing, or like the new thing that we're introducing here. Because again, everything else is pretty straightforward. So I think you guys will be fine with this actually. So let's go ahead and keep moving forward. Okay. So our robot makes its move, right? It has the ability to do that. So now we need to start our game of rock, paper, scissors. And what we'll say is, while true, because we're just going to have this run over and over and over and over again until they want to quit or something. The first thing we want to see, we're going to check our user's input, right? So user input, actually, we'll call it user choice, is equal to the input rock, paper, or scissors, right? And they'll type in rock, paper, scissors, or whatever they want. And then we'll say my robot's choice, right? Robot choice is equal to whatever move it makes, robot move, right? And then from here, we've done this before. Typically what you do is you just check to see if it's a tie first. You say if user choice is equal to robot choice, right? If they're the same thing, then you're going to print, it's a tie. It's a tie, right? And then what we did after that, I don't remember which lesson it was. I would have pulled up the REPL then. But what we do is we check to see if my user has checked, if my user picked a rock, then we have a nested statement to check then to see what my robot would put. So let's implement that and you'll see what I'm talking about. Let's say my user said rock, okay? So if my user said rock, that means my robot either said paper or scissors, right? Because if they had said rock, then it would have been a tie right up here. Let's say if my robot choice, so again, my user choice is rock. So if my robot choice is, say, scissors, right? So again, my user's this hand, my robot's this one. One puts down rock, the other one puts down scissors. Who would win? The scissors would win. So that means the robot would win that. So we'd print the robot wins. So if the robot puts scissors, and again, we already checked for rock up here, that means the only last thing I could possibly have is paper, right? If the robot puts, or sorry, the user would win here because rock beats scissors. But in this else statement, we're basically saying that the robot would have put paper. So if they put, the robot puts paper and the user puts rock, we know that our robot would win. So the robot wins. And again, let's go ahead and test this little snippet out just to make sure it works. Because again, it's just the same thing duplicated. We're just changing rock, paper, and whatnot. So rock, paper, scissors. So again, we need to put rock here. So we say the robot wins. So that means that the robot had put down paper. And just to make sure that's clear, let's actually go ahead and print that out here. Let's stop this, run this. I'm going to say rock. The robot said scissors. So if I put rock and the robot says scissors, that means that I would win. And that's exactly what happens here. So I had this, and then we came down to this if statement, and then I won. So is everyone okay with this block of code right here? Lines 19 to 23, how we're using this nested if statement to check the plays that our user is making. Are we all good on that?
Yeah.
Okay, perfect. Thank you. So from here, it's basically just copy and paste. So that's literally what I'm going to do, actually. I'm just going to copy this, paste it. Oops. Make sure you have the indent, guys. Okay. So again, this is checking for if the user put rock. The next thing we want to change is, let's say the user put scissors, right? If the user put scissors and the robot put paper, that means the user would win. That's literally all we have to change. So again, user put rock, user put scissors, user put paper. Now, if the user put paper and the robot put rock, then the user would win and the robot, and then otherwise the robot would win. And that's it. That's our whole game of rock, paper, scissors right there. And if I run this, see, I'll put rock. These you had rock, so it's a tie. I put rock, is paper, so then they would win. If I put paper, they put paper, it's a tie. If I put paper again, they put rock, that means I win because paper beats rock. So yeah, pretty straightforward, nothing too complicated. Again, the only like interesting thing we put in here was just this little chunk of code right here to add random moves, basically. And again, we can add like functionality like quit the game afterwards, but I'm pretty sure we've already built that, so there's no need for us to waste any more time. I'm actually not going to save this one because we've done it so many times. So we're all good with that. Pretty straightforward, nothing too crazy. So there's 2 projects left. We have about 15 minutes left. I don't mind going over time a little bit. I don't care. I mean, so the last 2 were either the card number game, so it's just a card game basically, or our Pig Latin translator. And I'll actually leave it up to you guys. Which one do you want to do? Let's do one more to wrap up lesson 10. So you can either choose a card name or you can do Pig Latin. They're both pretty interesting. They're both fun games at the end of the day. So whatever you guys are feeling, I'm down to just build it. I'm always down to do whatever. Oops. There we go. Okay. Dang, my thing keeps disconnecting. Come on, guys. Which one? Which one are we feeling? We can get like one more, maybe. My vote is Pig Latin, but is not working. Yeah, I think so, because I just opened this. Because I'm on Google Chrome, right? This is where the stream is. I just opened up another browser to check because I was like, why is this not? Because I figured you guys were probably typing something, but I couldn't see it. Here, let me open it one more time. Yeah, chat is not working. Sorry, I just missed all the last couple chats you guys have put in. Sorry. Number can't begin with 0. Yikes, yours is much better than mine. Dude, don't worry. Sorry, guys. It looks like chat was just a little bugged. My vote is Pig Latin. Okay. I can see chat now, though. I opened up a new browser to do it. So let's do Pig Latin. And again, I have my new chat, so hopefully we'll be okay. So I've opened up 2 sites, and again, awesome job, Luke. You did pretty awesome with your code. So Pig Latin. First, let's go over the rules with Pig Latin. So there's actually this one's a better site. It's pretty straightforward. So if a word begins with a vowel, so A, E, I, O, U, or Y, or A, E, I, O, U, just add yay to the end. Okay? For example, out is translated to out yay. So A, E, I, O, U, so my word out starts with a vowel, right? And because it starts with a vowel, I'm just going to add yay to the end of it. So it's out yay. If it begins with a consonant, then we take all the consonants before the first vowel and we put them at the end of the word. So we have which, right? W-H-I-C-H. A-E-I-O-U. So I is the vowel in this word. So we're going to take that W and that H and we're going to move it to the end. And then we're going to add A-Y to the end of it. So let me use this as an example. So again, let's say my name, let's say I wanted to say apple, right? Because apple starts with a consonant, right? Or sorry, a vowel, A, E, I, or U, we're just going to add yay to the end of it. But if you had something like my name, right, Varun, then A is the first vowel. I always get those confused. It's the first vowel that appears. This V is a consonant. So we're going to take this V and we're going to add it to the end, right? This V gets moved to the end, and we add AY. So it's really simple. And yeah, I'm pretty sure I put the link to the rule set above, so you can check that out if you just want to have like another reference or something. Okay. So let's get started. We're going to call this pig Latin, and this is going to be some good review for our strings translator. So let's just establish the rules really quickly. Literally just copy this. So we have something to reference. We don't have to go back and forth with this site. We've got that all squared away. So this pig Latin translator is just going to do one word at a time. We'll add like sentences and stuff later, so there's no need for us to have like a while loop or whatever. We'll just say user word is equal to input, and we'll say type in the word you would like to translate to pig Latin. Okay, and we'll type that in, right, and it'll get saved as a string, which is just what we need. Let me make this a little bit smaller. You guys can still see it. Okay. All right, so we'll type this in. I'll say Varun, and everything works just fine. Okay. So if a word begins with a vowel, if a word begins with a consonant, well, we have to have some way for our words, or sorry, our code to know what is a consonant, what is a vowel. So we're going to learn another import, and it's not really super duper useful like random and time, but for what we're doing, it's pretty helpful. It's going to save us a little bit of time. So what I'm going to do is I'm actually going to say import string. Okay, pretty straightforward, pretty simple. Okay, so I'm going to import string. And once I do that, we're going to come down here. We're going to say print string dot ASCII, ASCII, undercase, lower case. If I run this, get all these letters. Wait. Actually, never mind. Never mind. This I just realized this is not useful. Wrong project. Sorry. But we could do, sorry, I apologize. That was a mistake. What I meant to do was we're going to create two variables, right? Vowels, and we're going to have consonants. And in them, we're going to just put all the variables, or sorry, all the vowels and all the consonants. So vowels, that's A, E, I, O, U, right? Consonants, that's everything that's not a vowel. So I'm just going through the keyboard layout. So that's Q, W, R, T, Y, P, S, D, F, G, H, J, K, L. I'm actually going to go ahead and copy this and put it into our chat as well. You don't have to worry about typing all that stuff in. There we go. Did that load? Maybe the chat's not working. Yeah, I don't think chat's working, which is a real bummer. You guys can still hear me, right? Like I sound fine? Okay, good. Okay, so let me continue. We've got all of that, right? A, E, I, O, U, yada, 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 yada. So we've got all of our vowels and we've got all of our consonants. And basically what we're going to do is we're just going to check to see, the first thing we need to check is we're going to work on this first part right here. If a word begins with a vowel, right, just add, this looks like this guy had some spelling errors, just add yay to the end. So how do we check to see if, the first letter in a word is a vowel? Well, we can say if user word at the index of 0, right? Again, this is going to take our whole word and it's going to pull the thing at the first index. That's the first letter. So if the first letter in my user word is in my vowels string, right? That means it is a vowel. Now we're going to print out this word begins with a vowel, just to test it out, just to make sure it's all working. From this, I'll say, I will say apple again. And this word begins with a vowel, so we know it's working. So basically what we're going to do here, we're just going to add yay to the end of it. So we're going to say translated, right? Because we're translating from English to Pig Latin. We're going to say that's our user word. Actually, we're going to make this an F string. F string. We're just going to put yay at the end. If we print out our translated word, translated, we get, so I put apple, we get apple yay. So it looks like it's working pretty well. Are we all good with what I've done here? Okay. Unless you see any questions today, learn you can use F string out of statements. Yeah, you can use F strings to create new strings in general. It's commonly just used within print statements because it's just nice to like format those things into it. We could very well have said, here, let's get rid of this. If you remember our nasty addition syntax from when we first started, we could actually do something like this. So just user word plus yay. We're adding yay to the end. But you know, guys, I hate that. It looks so nasty. I prefer very much so our F strings, which just look infinitely better. So we're going to stick with that. So we've translated it. And so if our word starts with a vowel, we're just going to go ahead and add yay to the end. And again, let's do one more example. I'll say orange. And when I run this, we should hope to see orange yay. And that's what we see. So that's if our first letter in our word is a vowel. If it begins with a consonant, then we need to take all the consonants before the first vowel. So let's think about this. And we're going to use the which that it had. Let me actually print translated. Anyway, so let's work on this second rule right here. If my word, for example, is which, right? Let's try to think about how we as humans are processing this. Maria asks, what does 0 represent in user word again? Again, we're sorry. Our user word is a whole string, right? And so that 0 is used to pull the first letter, if you remember with our indices. So if I had like, let me say, print user word, we'll put 0. So if I run this one more time, we'll type in orange. It gives us O because it's at the index of 0 within my string. It's just we're using indexing one more time with our strings to pull the first letter. So if I run apple, we get A, and that A is within my vowels string. So that's where we're able to translate it. Intelligent. That I is the first letter, index 0. We check within our vowels. We add yay to the end. So that's what that's used for. So yeah, let's go back to our which example. Which, oops. All good, bro. Those brackets are commonly used, or most of the time when you see a bracket and they have numbers in it, just think indexing. That's usually what it is most of the time. So we have which. We need to basically go up to our I, our first vowel, take everything before it, add it to the end, and then add AY to it. How can we do that? Let's think about this a little bit. We need to go up to our first vowel, take everything before it, and then add it to the end. Any thoughts, any ideas that we have passing around in our heads? What do we think, guys? I think my chat's broken again. It just does. I haven't seen like the last couple. All right, we're just gonna keep going then. So what I think we should do is we're going to create a for loop, right? That's basically going to go over each item in the word, right? And once it comes across a digit that is a vowel, it's going to save that index, right? That address of that character, and it's going to take everything before it, and we're going to create a substring. So let's go ahead and try that. So again, we're just going to add an else statement here, because if the first word is not a vowel, that means it is a consonant. So what was I going to say? Oh yeah, for loop. So for I in range within the length of my user word, let me print this out, print I should see. So if I put Varun right here, let's get rid of this actually. If I print Varun, we get 0, 1, 2, 3, 4, right? So these are all the indices of all the characters within my name. So V is 0, A is 1, R is 2, U is 3, N is 4. If I put Luke, again, so it's all, we're using this length function to help us out here. And we've done that before. So we need to go over every item in our word. And if that item is a vowel, then we can sublist. So let's go ahead and try that out. So I'm going over each item. So I need to say character is equal to user word at whatever index, right? That index. I put my name again. Oops, let's print out character as well. I and character. Okay. So what we need to see is if our character is in vowels, right? So we're going through each thing one by one. And if our character is in vowels, what we need to do is we need to have sort of a variable here. We'll call it first vowel index. We'll set that equal to 0 for now. If my character is in vowels, we're going to say my first vowel index is equal to I. Okay, I'm going to put a space right here. I'm just going to print. So I'm going to break out of this as well. First vowel. I'll explain this because I know I'm going kind of quick. Let's run this. We're up here. We're going to type our input, VARUN. And it doesn't start with a vowel, so we're going to skip this. We're going to come down here. My first vowel index is equal to 0. That's sort of our way of storing where our first vowel is showing up within our string. So again, we're going to go over each character. All right, so I'm going over the V, right? So that's the first character in my name. It's that index of 0. And so if I print that out, you get 0V. That makes sense. Now we're going to come over to the second letter in my name. So we have the A, and that is a vowel. So we're going to print that out, right? So we have 1A. So is my character A in vowels? It is. So I'm going to say my first vowel index, right? Where is my first vowel popping up? Well, it's popping up at the index of 1, wherever my A was at. And then we're breaking out of this. Are we okay with that so far?
Yes.
Perfect. So we've got that saved where our first vowel is. So now we can create a substring. So a substring is just like sublisting. So we're just going to call this section to move, right? Because we're moving the section to the end, right? What was I going to do? Oh, so we have our user word, and we're going to get everything from the start to wherever our first vowel index is. So if I print this out, section to move, and we'll use which as our example. Remember which, right? The thing that we want to move is this W and this H. So when you print out section to move, it should hopefully be this. So I run this, we type in which, here we go. We get WH. That's the section we want to remove. If I did my name, so VARUN, the section I want to remove is just that V. There you go. That's the section we want to move. So we have the section we want to move. It's also good to keep the section we want to keep. So we say section to keep, and we'll just say, again, we're just slicing up our user word string. That's going to be from our first vowel index to the end. So just going to leave that there. So if I print section to move and section to keep, you'll see a space between the two of them. Oops. Run that. So if I type in which, what do we want to move? We just want to move this W and this H. That should be the first thing. We want to keep this ICH. If I type this, so that's our section to move, and our section to keep is just this. I run this with my name. We want to move the V, but we want to keep the ARUN. And that's what we're doing. And now we can sort of treat it like puzzle pieces, right? Because I have the section I want to move, I have the section I want to keep, and then I just know I have to add AY to the end. So we can just say, let's use an F string again. What comes first? Well, the section we want to keep comes first, right? So section to keep. And then we have our section to move, and then we have AY. We run this, we know that which, should become like, each way. So if I type in which, each way. Perfect. Are we all good with this section right here? I'm taking my string, cutting it into pieces, and then sort of moving the pieces into an order that I need it to go into. Because I know it's been a while since we've done this. Yeah. I'll tell you this. A lot of times with programming, it's really just knowing your basics. And that's actually why this course, like teaching this, has been really helpful to me as well. Because a lot of these things I forgot about as well. My camera's being a little cranky, but a lot of these things you just don't remember because you don't use them all the time. But sometimes they're what you need to solve the problem the best, most efficient way. And I actually have my code from when I did this. I don't know when I made this, but here, I'll bring it in so you guys can see what my code used to look like. And basically, and actually, let me just make sure. Are we all good with this before I do a little share time? Are we all okay with what I've got here so far?
Yeah.
Awesome, awesome. So yeah, we've come to the end of class, so we'll just have a little. I'll just share with you guys this nasty code I wrote. I don't remember when I wrote this. I think I was like 15 or something, or 14. So I used to be a fan of like asking for people's name and whatnot. You take the vowels, you take the consonants, and basically what I did was, oh god, I don't even remember. It's so it's so nasty, guys. But what I did was I had three functions, right? And essentially the point of these functions was to break my string down into different components. It went letter by letter, if it makes sense. But yeah, really nasty, really gross. this looks a lot better. It's a lot shorter as well. Yeah, a lot of the projects that we've built or that we're building, they're projects that I built years ago. I have them all saved. And so once we build them now, we'll go back and take a look at what I used to do. Oh my god, it was so bad. But anyway, before we forget to do anything, let's go ahead and save this. Pig Latin. We rename that. I forgot the .py. Yeah, we've got that saved there. And it is 140, so we didn't go too much over time, but that is lesson 10. So, guys, it has been a pleasure. It's been really fun. Thank you guys for the questions and whatnot. Would you mind explaining the number card game in case I want to start it? Of course. That's such a great idea. I'll give you something to work on over the week. I'm trying to remember what it is. Let me open up main.py and I can write it out. So basically, I don't remember like the exact rules because I made this game. But basically, what it is there's two players. Obviously, one of them will be a robot. So we'll just say one robot. Each player, actually, we'll say both players get numbered cards from 1 to 12. Right? So you have 12 cards in your hand. Each card has a 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, right? Each round, the player puts down a card. The card with the highest value wins. It's really easy. Again, this is a game I made just to keep practicing. So let's say I'm playing against Luke, right? We have our 12 cards. I have my 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Luke has his. We start. I put down a 6. Luke puts down a 12. Luke would win that because 12 is obviously greater than 6. So the only interesting part about this game is sometimes you have to like change up the order of how many cards you win or like what card you want to put down. So yeah, it's really simple. So the robot will just pick a random number from its. So robot just picks random number from its deck, and your deck is basically just a list of integers. That's basically all it is. Holy crap! My friend and I created this game in 4th grade. We called it Mexican Standoff. I created a name for this one as well. I called it Jungju. Jungju, I think that's what it was. Yeah, that is y'all's project for the week. If you get time to look at it, it's worth it. It's pretty simple, not as hard as the Cows and Bulls game, which was definitely more advanced. But yeah, it's been a good stream. Thank you guys for putting up with all the technical difficulties because they were there. So yeah, review. So do we feel like we need a review on this? Because if we do, then we'll definitely do it. But if we're feeling all right, then we can save all the project building for our next lesson. What are you guys feeling? Well, yeah. Do we feel like we need a review, or are we okay with what we have so far? No need for review, I don't think, but I'm willing to meet tomorrow to do more building. Just as happy waiting till next week, till if that's better. You know what? We'll do tomorrow's class, and we'll just build a card number game. We'll just save us time for the next lesson because we're just gonna keep building for a while now. It'll be short, and we definitely won't make it to 30 minutes because it's gonna be super simple. It'll probably only be like 10, 15 minutes. But we don't have anything else to cover, so yeah, it'll save us time later. Awesome. So again, thank you guys for putting up with all the technical difficulties that we faced. I'm glad we were able to overcome it. And again, thank you guys for participation and whatnot. And shout out to Luke for being a good programmer. I mean, he did good. So anyway, let's go ahead and call it for today. I'll see you guys tomorrow, 12 p.m. Eastern Standard Time. It'll be short. Don't worry about it. Anyway, take care, be safe, and I will see you guys then.